Hello everyone and welcome again to my How To Education channel. As I promised you last week, we will continue with the derivatives today and speak about the product rule. After watching this video, don't forget to leave me your feedback. Let's suppose that there exists a function f of x, which is the product of two other functions, also in terms of x. That is, f of x equals g of x times h of x. As for example, f of x equals x cubed times the cube root of x minus 3, which is the product of x cubed and the cube root of x minus 3. In order to find the derivative of such functions, we follow the general format. F prime of x equals g prime of x times h of x plus h prime of x times g of x. Let's apply the above formula on the above example. If f of x equals x cubed times the cube root of x minus 3, then g of x equals x to the 3, and h of x equals the cube root of x minus 3. If g of x equals x to the 3, then g prime of x equals 3x squared. If h of x equals the cube root of x minus 3, then h prime of x equals 1 over 3 times x minus 3 to the power minus 2 over 3. As seen before, the general format in this case is f prime of x equals g prime times h plus h prime times g. Thus, f prime of x equals 3x squared times the cube root of x minus 3 plus 1 over 3 times x to the 3 times x minus 3 to the power minus 2 over 3. In order to make sure that you grasp the product rule, I would recommend that you pause this video and try to solve these exercises before I give you the solution. F of x equals 23x times x plus 20 to the power 4. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is 23x and h of x is x plus 20 to the 4. If g of x is 23x, then g prime of x is 23. If h of x is x plus 20 to the 4, then h prime of x equals 4 times x plus 20 to the 3. Therefore, f prime of x equals 23 times x plus 20 to the power 4 plus 4 times x plus 20 to the 3 times 23x, which is 23 times x plus 20 to the 4 plus 92x times x plus 20 to the 3. F of x equals 4x times 9x to the 6 plus 3x to the 10. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is 4x and h of x is 9x to the 6 plus 3x to the 10. If g of x is 4x, then g prime of x is 4. If h of x is 9x to the 6 plus 3x to the 10, then h prime of x is 54x to the 5 plus 30x to the 9. Thus, f prime of x equals 4 times 9x to the 6 plus 3x to the 10 plus 4x times 54x to the 5 plus 30x to the 9. F of x equals x to the 5 times 3x plus 9. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is x to the 5 and h of x is 3x plus 9. If g of x is x to the 5, then g prime of x is 5x to the 4. If h of x is 3x plus 9, then h prime of x is 3. Therefore, f prime of x equals 5x to the 4 times 3x plus 9 plus 3x to the 5. The derivative can be expanded and then simplified into 18x to the 5 plus 45x to the 4. f of x equals 18x squared times 42 plus x to the 14. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is 18x squared and h of x is 42 plus x to the 14. If g of x is 18x squared, then g prime of x is 36x. If h of x is 42 plus x to the 14, then h prime of x equals 14 times 42 plus x to the 13. Therefore, f prime of x will equal 36x times 42 plus x to the 14 plus 252x squared times 42 plus x to the 13. f of x equals 8x to the 24 times 91 plus x to the 54. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x equals 8x to the 24 and h of x equals 91 plus x to the 54. If g of x equals 8x to the 24, then g prime of x equals 192x to the 23. If h of x equals 91 plus x to the 54, then h prime of x equals 54x to the 53. Therefore, f prime of x equals 192x to the 23 times 91 plus x to the 54 plus 54x to the 53 times 8x to the 24. The derivative can be expanded and then simplified into 17,472 x to the 23 plus 624 x to the 77. f of x equals 12x to the 3 times minus 2 plus x to the minus 23, such that x is different from 2. First of all, I mentioned that x should be different from 2 because f of x equals 12x to the 3 times minus 2 plus x to the minus 23, which is 12x to the 3 over minus 2 plus x to the 23. Thus, if x is 2, f of x will have a zero denominator, which is not possible. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is 12x to the 3 and h of x is minus 2 plus x to the minus 23. If g of x is 12x to the 3, then g prime of x is 36x to the 2. If h of x is minus 2 plus x to the minus 23, then h prime of x is minus 23 times minus 2 plus x to the minus 24. Therefore, f prime of x equals 36x to the 2 times minus 2 plus x to the minus 23 minus 23 times minus 2 plus x to the minus 24 times 12x to the 3. x to the 3 over 4 times 37 plus x to the minus 3, such that x is greater than or equal to 0, is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is x to the 3 over 4, and h of x is 37 plus x to the minus 3. If g of x is x to the 3 over 4, then g prime of x is 3 over 4 x to the minus 1 over 4. If h of x is 37 plus x to the minus 3, then h prime of x is minus 3, 37 plus x to the minus 4. Therefore, f prime of x equals 3 over 4 x to the minus 1 over 4 times 37 plus x to the minus 3, minus 3 times 37 plus x to the minus 4 times x to the 3 over 4. f of x equals 2x times x minus 3 to the power 1 over 3. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is 2x and h of x is x minus 3 to the power 1 over 3. If g of x is 2x, then g prime of x is 2. If h of x is x minus 3 to the power 1 over 3, then h prime of x is 1 over 3, x minus 3 to the minus 2 over 3. Therefore, f prime of x is 2 into x minus 3 to the 1 over 3 plus 1 over 3 times x minus 3 to the minus 2 over 3 times 2x. Nevertheless, what the question is asking is to find the derivative at a specific point. A point 1144 means that x is 11 and y is 44. Thus, to find f prime of x, we need to replace x by 11, which yields 70 over 12, which is 35 over 6. F of x equals 2x minus 2 times x minus 5 to the power minus 1. The given function is a product of two other functions, both in terms of x. Thus, it follows the general format. F of x equals g of x times h of x, where g of x is 2x minus 2 and h of x is x minus 5 to the power minus 1. If g of x is 2x minus 2, then g prime of x is 2. If h of x is x minus 5 to the minus 1, then h prime of x is minus 1 x minus 5 to the minus 2. Therefore, f prime of x equals 2 times x minus 5 to the minus 1 minus x minus 5 to the minus 2 times 2x minus 2. Nevertheless, what the question is asking is to find the derivative at a specific point. A point 7, 6 means that x is 7 and y is 6. Thus, to achieve f prime of x at 7, 6, we need to replace x by 7, which yields 1 minus 12 over 4, which is minus 2. Find the points where the gradient is 0 on the curve with equation f of x equals 3x plus 2 times x minus 1 squared. As we know from part 1, gradient means derivative. Therefore, we need to find the points that make f prime of x 0. In order to do that, let's first find f prime of x. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is 3x plus 2 and h of x is x minus 1 squared. If g of x is 3x plus 2, then g prime of x is 3. If h of x is x minus 1 squared, then h prime of x equals 2 times x minus 1. Therefore, f prime of x equals 3 times x minus 1 squared plus 2 times x minus 1 times 3x plus 2. F prime of x equals 3 times x minus 1 squared plus 2 times x minus 1 times 3x plus 2 can be written as f prime of x equals 3 times x minus 1 times x minus 1 plus 2 times x minus 1 times 3x plus 2. Since x minus 1 is a common to both terms of the polynomial, we can factorize it and rewrite it as f prime of x equals x minus 1 times 3 times x minus 1 plus 2 times 3x plus 2. Thus, f prime of x equals x minus 1 times 3x minus 3 plus 6x plus 4, which is x minus 1 times 9x plus 1. F prime of x will be 0 either if x minus 1 is 0 or if 9x plus 1 is 0. Thus, x is 1 or x is minus 1 over 9. If x equals 1, then f of x equals 3 times 1 plus 2 into 1 minus 1 all of it squared, which is 0. If x is minus 1 over 9, then f of x equals 3 times minus 1 over 9 plus 2 into minus 1 over 9 minus 1 all of it squared, which is 500 over 243. Thus, the points where the gradient is 0 are 1, 0 and minus 1 over 9, 500 over 243. This is it from math for this week. Don't forget to give your friends and acquaintances the opportunity to have access to these videos by liking, sharing, commenting, and subscribing to this channel. We will be continuing with the quotient rule of derivatives next Monday. But before then, I will see you all on Wednesday with some economics content. Thank you so much.